When we gaze into the vast, awe-inspiring expanse of the cosmos, countless stars shimmer in the darkness, yet only one reigns supreme in our sky and in our daily lives: the sun. Blazing with relentless power at the very heart of our solar system, it burns with such intensity that ancient civilizations crafted entire mythologies to explain its mesmerizing glow. To them it was a god, a force beyond comprehension. To us it remains the life-giver, the source of light and warmth, and the constant reminder that we orbit a raging inferno. But as our technology has leapt far beyond the dreams of those early stargazers, we can now peel back the sun's mysteries in ways they never imagined. Today, humanity is able to journey deeper into its turbulent atmosphere, exploring layers of fire and plasma where unimaginable forces collide. It is here, within this ferocious brilliance, that phenomena both terrifying and beautiful come to life. Solar flares that erupt like cosmic tempests, rivers of glowing plasma arching across space, and rain made not of water, but of fire. I'm Mike, and you're watching Lumora. In this video, we will venture closer than ever into our star. We will travel through wavelengths of light invisible to the human eye, unravel secrets written in ultraviolet and X-ray fire, and see the sun not as a simple glowing disk, but as a living, breathing engine of creation and destruction. Although light is the fastest traveler in the universe, the image of the sun we see from Earth is never truly in the present. Every time we look up, what reaches our eyes is already history, about 8 minutes and 20 seconds old. That means the blazing sphere we watch rising at dawn is not what exists above us now, but what it looked like moments ago. In the scale of the cosmos, we are always watching the past, and if we trace the journey of light back to its origin, the story becomes even more astonishing. Photons are born in the sun's dense nuclear core, where hydrogen atoms are fused into helium under unimaginable pressure. But once created, these tiny messengers of energy face a long, chaotic path. They scatter, bounce, and collide their way through the star's many layers, trapped for ages within the churning plasma. It can take anywhere from 10,000 to 170,000 years before a photon finally reaches the surface and escapes into space. Only then does it race across the void to arrive here, warming your skin and lighting your day. So when sunlight pours through your window, you're not just seeing energy from moments ago. You're witnessing the result of a journey that began long before humanity even existed. Each ray of light is ancient history, a relic from the deep heart of the sun, carrying with it the story of time itself. The outermost layer of the sun's atmosphere is the corona, a faint halo of fire stretching millions of kilometers into space. Most of the time is drowned out by the blinding brilliance of the photosphere, invisible to our naked eyes. But during a total solar eclipse, when the moon perfectly aligns and blocks the central disk, the corona reveals itself in fleeting splendor, shimmering ghostly tendrils of light surrounding the darkened sun. It is a vision so breathtaking, ancient peoples thought they were witnessing omens from the gods. Thanks to NASA's Solar Dynamics Observatory, launched in 2010, we no longer have to wait for rare eclipses to study it. By capturing the sun in extreme ultraviolet light, the SDO unveils hidden structures of plasma at temperatures reaching 1,000,000 Kelvin. These images show us the corona in dazzling clarity, far beyond what the human eye can perceive. Within this halo, we find darker regions known as coronal holes, zones where the sun's magnetic field lines open outward into space. From these holes streams the solar wind, a relentless flow of charged particles racing across the solar system. When this wind collides with Earth's magnetic shield, the night sky at the poles bursts into color, painting curtains of green, purple, and crimson light. The aurora, beautiful and mysterious, is a living reminder of our connection to the sun, an earthly dance choreographed by cosmic storms. A sun is never still. Beneath the calm glow we see from Earth, its atmosphere is a battlefield of magnetic forces twisting and snapping with terrifying violence. One of the most spectacular events born from this chaos is the solar flare. These colossal explosions occur when magnetic field lines tangle and suddenly realign, unleashing bursts of radiation so immense they can outshine the rest of the sun for minutes at a time. Watching them erupt is both hypnotic and unsettling, like witnessing the breath of a cosmic dragon. But flares are not the only marvel. Enormous arcs of plasma, known as solar prominences, rise from the surface and loop far into space. Some stretch hundreds of thousands of kilometers, dwarfing Earth into insignificance. They can last for days, or even months, suspended by magnetic fields until the balance breaks. Sometimes, instead of dispersing outward, this plasma cools and rains back down, falling as fiery showers across the sun's surface. This coronal rain is breathtaking to watch, glittering like liquid fire, though each drop burns at millions of degrees. At times, the tension snaps violently, unleashing coronal mass ejections, massive eruptions hurling billions of tons of plasma into the solar system. If one were to strike Earth directly, it could overwhelm satellites and disrupt entire power grids. These storms remind us of how fragile our modern world is against the fury of our star. The sun is both a giver of life and a looming source of cosmic danger, a paradox that makes it all the more captivating. Venturing deeper into the sun, past the corona, we arrive at the chromosphere, a turbulent sea of plasma, about 1,700 kilometers thick. Seen through ultraviolet light, it reveals a mesmerizing forest of spiculars, thin jets of fire shooting upward like blades of grass swaying in the wind. Each one races skyward at nearly 100 kilometers per second, faster than the speed of sound hundreds of times over, and they rise taller than Mount Everest before vanishing within minutes. For decades, their origin was a mystery, until scientists discovered that neutral particles gave charged plasma the buoyancy it needed to break free, piercing through the sun's magnetic grip. Below this layer lies the photosphere, the sun's apparent surface and the source of its blinding light. Though it looks solid from Earth, it is nothing more than a seething plasma ocean about 400 kilometers deep. Under close inspection, dark patches appear, sunspots. They are cooler regions where intense magnetic fields trap heat, making them stand out against the fiery background. Intriguingly, these sunspots often coincide with solar flares, hinting at the magnetic storms brewing beneath. Even more astonishing are the solar granules, vast convection cells bubbling across the photosphere. Each one is wide as 1,000 kilometers, like boiling water magnified to a planetary scale. Hot plasma rises at the center of each granule, spreads outward, cools and sinks along the edges, creating a never-ending cycle. Together, These patterns paint the sun not as a static sphere, but as a restless, breathing entity, forever reshaping itself through waves of unimaginable energy. And so our journey into the sun ends here, at the photosphere, the deepest layer humanity can directly observe. Beneath it lies a world forever hidden from our eyes, a realm of plasma and pressure where the very heartbeat of our star is born. What exists below remains cloaked in mystery, waiting for the tools of future generations to uncover. Yet, even without peering deeper, we've already witnessed wonders that defy imagination. Exploding solar flares, vast coronal holes, shimmering auroras, spicules dancing like firegrass, sunspots that betray magnetic tempests, and granules that churn with the rhythm of an endless storm. Through the spectrum of invisible light, we've peeled back layers of fire and plasma, discovering a sun that is not merely a glowing disk in the sky, but a living, dynamic engine shaping the destiny of our world. It is both beautiful and dangerous, nurturing life with its warmth, while holding the power to disrupt the fragile systems on which our civilization depends. And perhaps that is why it captivates us so deeply, because it is a paradox we can never escape. One day, science may let us see even further into its blazing core. But for now, the knowledge that each ray of sunlight is a gift from the depths of time should fill us with wonder. There is still so much unseen in the universe, waiting to be revealed. I'm Mike. This is Lumora. And together, we will continue seeking the hidden truths of our cosmos.